Hey guys, I just wanted to go over the answers to the practice you did in the surface area of 3D shapes packet yesterday before you continued practicing today. So if you haven't yet, please take that packet out and we're going to go through the examples real quick. I'm going to go pretty fast because you can always pause the video if you need to look at my answer keys for longer. And if you don't, I don't want to hold you up. So here we go. I'm on the third page. This is the first example for finding the surface area of a rectangular prism. Pretty straightforward. The net is already drawn for you. You've got 6 faces, 3 different rectangles. I'm going to jump right to the answer for this one. Each rectangle is found by doing base times height. Find your 3 different areas and go ahead and add them all up. It's totally fine if you added these in a different way. Maybe you did 30 times 2 plus 18 times 2 plus 15 times 2. Maybe you did 30 plus 18 plus 15, then that whole sum by 2, as long as you got 126 inches squared at the end, and I can follow your work similar to how you can follow mine, we are good to go. All right, on to number 2. Similar idea, but you had to draw the net first. A quick little tip, when I go to draw my nets, I usually identify what I'm going to use as my bases, or what are the bases on shapes when you don't have a choice. So I use those two, the bottom and the top, as my bases, and then just kind of imagined unfolding these 4 other rectangles from there. And then similar to last time, we've got 3 different rectangles, have to multiply them all by 2. Here is my work, right? So you can see my net, there's the base, kind of unfolding the 4 rectangles. The other base attaches anywhere, could be here, here, here. Find the area of the 3 different rectangles, all using base times height. Add everything up in some way for 166 inches squared. All right, turn the page in your packet so that you are looking at this example for the surface area of triangular prisms. This one, you were told that the triangles are equilateral, so all the sides are congruent or equal. What does that mean for the rectangles? We know this side is 3 inches, so this must also be 3 inches because those will meet up together when you fold the shape. And it's an equilateral triangle, so this must be 3 inches and this must be 3 inches. And then these are going to fold together, so this must be 3 inches. So all 3 rectangles are 3 by 5. We have congruent rectangles, which makes this only have 2 different areas to find, which is nice. So here's the work. The bases are triangles, each have an area of 3. The faces are rectangles, each have an area of 15. Add up all 5 sides in some way for 51 inches squared. Remember, again, you can always pause the video if you want to look more closely at any of my work. On to number 2. You had to draw the net first on this one. Just like before, I like to identify the bases. So in a triangular prism, the bases are triangles. And then we've got 3 rectangles kind of wrapping around from there. But let's hone in on this. I told you that the triangles are scalene. They have no equal sides, no congruent sides. So what does that mean for the rectangles? On the bottom here, this rectangle is 4 by 6. Then over on the side, this rectangle is 5 by 6. And in the back, this rectangle is 3 by 6. Can you guys hear my cats having a brawl in the background? Hey, enough. Sorry about that. Yeah, so we have 3 different triangles. So you actually had 4 areas to find for this one. Here is what my work looks like. We've got the triangular bases, the 3 different rectangles, add everything up, make sure you add the bases twice, 84 inches squared. Turn the page again in your packet so you are looking at the surface area of pyramids practice. Here is the first one with a square base, which is nice and convenient because that means all of these sides are the same 4 inches. So which means all of these triangles have to have the same height of 3. So just 2 different areas to find. Here's the area of the base. The area of one of the faces is 6. You need to add that 4 times, plus the 16 gives you 40 inches squared. On number 2 on this one, this is a little trickier. We've got a triangular pyramid. So now the base is a triangle, in addition to all of the faces being triangles, but those triangles are different. So what do we got going on in this picture? We've got this triangle on the bottom is 6 feet. Oops, fun little line there. Let's get rid of that. This is 6 feet, and what I was trying to... All right, let's do this first. It tells us here that the base is an equilateral triangle, which means all the sides are the same. So if this, oops, where's my color? If this is 6 feet, then so is this and this. So all of these triangles wrapping around here, that meeting at the point, the faces are all going to be the same triangle because they all have a base of 6. And then this right here is their height of 12. But then the triangle on the bottom is different because it has a base of 6, but filling in here, it tells us that that triangle has a height of 5.2. So here you go. Here's my net. The area of the base, the area of the 3 faces, add everything up, 123.6 feet squared. Now, hopefully the sub gave you the message yesterday that you did not need to finish the 2 try these questions for homework if you didn't finish them in class, but I want to give the answers still for those of you who got here. So pretty quick, the catch is here that we've got 2 shapes. We've got a rectangular prism and a rectangular pyramid, and we're covering the whole thing in paper. So what that means, though, is that this rectangle right in here, which is the base of the pyramid, and one of the bases of the prism doesn't get counted because it's inside the shape. It's not going to be covered with paper. So when you found the area of the triangular, the surface area of the rectangular pyramid, it's just 4 triangles, 2 different triangles, but 4 triangles, no base. And then when you find the surface area of the prism, it's only 5 of the sides. And you don't want to count that top face. So I'll just show you my answer. You can pause and check it out further if you want. How do I get back to the cursor? There we go. So I got 1,600 centimeters squared. Again, pause if you want to check out my work any closer. For number 2, the catch here is that we've got a hexagonal prism. So we need to find the area of this hexagon, but we have no formula to find the area of a hexagon. So you had to use my little hint here, which tells you that you can split a hexagon up into 6 congruent triangles. So starting from the midpoint, if I connect a line out to each vertex, we get 6 congruent triangles, and you can find the area of those. So here is my work for this one. Again, you can pause to look at it more closely. I got 1,627.2 inches squared. All right, hope you're having fun. Bye.